I'm really excited to be talking about something that's absolutely brand new for Great Expectations, but a feature I'm really excited about. So this is sort of the soft launch preview release that you're getting to see here. And that's exploratory data analysis with a new feature called rule-based profilers. Really quick, just about Superconductive. We're the team behind Great Expectations. For me, what you're about to see is very, very near and dear to my heart because it really helps with blending quantitative and qualitative analysis, which is where I've spent most of my career in finding ways that we can improve communication between teams that are primarily focused on their subject matter expertise as their supporting decision making, and teams that are quantitatively driven and model driven, like your ML teams. Great Expectations, just to give a little bit of language what we're going to be talking about, focuses on bringing the discipline and practice of software testing to the data environment. And what you're going to see when we talk about exploratory data analysis is very much in this language, this expectation-centric language that is a hallmark of Great Expectations. So we provide this declarative grammar that starts with things like expect the column to exist, these very schema-oriented, high-level characteristics, and progresses into more semantically rich expectations about data, looking at their specific values or distributions of values over columns. We talk a lot about a variety of different benefits. The beauty for rule-based profilers really comes down to two things. First is underscoring the translation layer between expectations about data and these natural language sentence representations of them that we create. And I'll talk for a second a little bit about sort of the history of exploratory data analysis, but the next big benefit is that we're providing checklists of questions. So again, these are two things that we've talked about for a long time of like why Great Expectations is useful, but we're really right at an inflection point in how that works. So exploratory data analysis is a term I think that we talk about a lot in the broader ML field, but going back to John Tukey's book, which, you know, he was just very revolutionary in a lot of different aspects of things that he did in the statistics community. But he took this very interesting approach to how we look at data and was trying to get people away from the notion of data as hypothesis testing and instead provoke a broader range of questions about how the data that we already have can be used, how it can be understood differently, what sort of hypotheses it might suggest that weren't already there to, you know, we weren't already going to test, and then critically, what other data to go get. And a lot of that is done through a very visual language where you're kind of letting the data talk to you. So how does that translate over into questions? I think what I've realized is a lot of times when you're first starting out on an ML project or you're a new person joining a project, you get down, you connect to the feature store, you see what you have, but you need to understand, what does it mean? Like, what are all the characteristics of these features or columns that I have available to me as I'm doing something? And often that looks very much like a kind of flowchart of questions. It starts off with this, like, what does my data look like? And, in Great Expectations, usually we think about it as then moving to these normative questions, like, does it look like it should? What does my data look like? That could usually be decomposed, right? Does it have null values it shouldn't? Is it distributed correctly, and so forth? But each of those have these more factually oriented questions that sit right behind them and that answer the normative question. So with rule-based profiling, what we're doing is we're really foregrounding all of those questions, and we're making it possible to effectively script out, but at a kind of a very semantic level, a general thesis for how you should go about looking at a new data set. And then that's something that you can compose, share, manipulate easily with your team. There are three key things that are, I think, really neat and kind of different in how we're doing rule-based profilers from how previous generations of profilers have worked. The first is that they're configuration driven. So like, this could be hopefully, I think you can think of this as a very good thing, because it means you're not in the realm of thinking about having to code things when you want to make a change to what the questions that you're going to ask are. At the same time, they're very customizable. So that could be that you're changing just the configuration, but it's also easy to slot in additional components. So if you have a different kind of way of generating a histogram or a plot or some other metric that you think is very important for your approach to doing exploratory analysis, no problem, you can put that in. And then lastly, they're very reusable. All right, very high level. I've got a little bit of snippet. Let me switch now and take a look at a notebook. So in this notebook, what I'm doing is I'm going to actually go through the process of running and explore one of these rule-based profilers, and then take a look at what we see as a result. And I think what I'm hoping to do in this is really trigger, there are all sorts of things I want to do next. So first, we're firing up a data connector. And if you're familiar with Great Expectations, this will be very familiar. And if you're not, it's very, kind of boilerplate. We're just basically providing access to one of the public, very common data sets, New York City taxi trip data. And then we have this profiler, and each profiler is composed of a number of rules. Rules take the form of a domain builder, or something that describes the part of the data set that we're going to describe. Expectation configuration builder. So the things that will define expectations, and then optionally, but critically for the story we're telling, these parameter builders, which are the things that go through and identify metrics. And so the thing that's really interesting that's going on here in this numeric range or metric range multi-batch parameter builder, wow, longest name ever, is that we're getting past just looking at the metric, and we're actually looking at a distribution of these metrics over some number of batches. So in this case, we're looking at the previous 11 months of data, looking at how over those months of data, the value in question, whether that's the row count or min values or max values, how that has been distributed. And then we're choosing a value based on a target false positive rate that will give us a picture sort of what the likely range of these values is. Really quick, last thing is I just want to show sort of what is some resulting elements of that. And so I've got a couple examples. First is an example of running the very basic kind of schema level profiler script against this taxi data, and then validating it. So critically, different than previous generations, or different than a lot of these kinds of systems, instead of being purely descriptive, we're describing on some large number of batches of data and inferring on some large number of batches of data, and then also looking at how our most recent data compares to that. And we can immediately just sort of at a glance get a picture of what kind of thing we're looking at, what kind of characteristics the data has. And then, of course, the thing that makes it really exciting is when we look inside of something and we start putting up the kind of classic two-key distribution plots or box plots. In this case, this is just a histogram, of course. But critically, instead of just being of the observed values, we're able to start comparing and looking over time at how our data is changing, all from this very simple scripting interface. So there's my super fast lightning version. And I think for me, what I'm super excited about here is that what we're trying to do is provide a framework that makes it possible to share entire workflows for how you go about exploratory analysis, and make it easier for people to jump in on a team, get right into the process of understanding a brand new data set, and then share those insights with other people and start locking them into expectations that can inform all their future work.